let's look at this CGI script on the web. So it's a supplier database. So you can search the database. Say name matches some regular expression pattern, or phone number matches some pattern. If you specify null, it lists all the entries. So right now the database has 2 entries: ID A001, name apricot, phone 224, and ID D001, name Dixon, phone 00. So you can change, say, phone number 00. You change it to 002 and do update. Then if you search again, it'll show that the updated phone number. And if you search for a match, say April star, it'll show you the name that matches regular expression APR star, which is apricot. Or you can search the phone number, say phone number 2 star. It'll list both of the entries, because 224 matches 2 star, and 002 also matches 2 star. If you specify 3 star, something's wrong. 3 star should match. No, actually, it's correct, because 3 star matches 0 or more 3. So essentially, it matches every string. So if you say 3 plus, I think it'll give you a null, give you 0 entries. So yeah, if you say 2 star, it doesn't really say anything. It essentially matches everything. So here, this is the database CGI. So this is actually a past exam question. I think personally this question is kind of too difficult for you to work out in an hour or so. So I think the questions on my exam would be easier. So here's the question. Web-based supplier database per CGI program. So the behavior is just what I showed you. The main program, you have a bunch of functions or subroutines. Read file, read in the file, and initialize a per hash structure. So you're reading the text file from the disk, and store the entries of the database in the main memory hash structure. So shell menu displays the GUI, the buttons, and the input boxes, etc. Edit data allows you to edit the records. Update data is when you click on update, it updates the hash structure. And finally, writes the data from the internal hash structure to the file specified by parameter file name. So assuming that you have these subroutines available to you, then the main program looks like this. First, this is should always be there, and then use CGI toward standard. So use the standard library so that you can write HTML documents easily from Perl. So say print header parentheses. This is the function, built-in function within the standard library. If you didn't include this line, you wouldn't be able to use this header and store HTML functions. So. And call shell menu, it displays the initial menu. So let's do refresh. So that's the initial menu, show menu. And if param query, so this is when you click on the query button, then it reads in the file supplier.dat and edits data. If param update, this is when you have displayed the database, and then you click on update button to save what you have entered on the web form to the server. So this is if param update. Then you read the file, update data, and write the file. And finally, you do print and HTML. So when you start up initially, so say we invoke this database.cgi, this CGI program initially, you haven't clicked on the query or data or update buttons. Therefore, both of these if statements will not be executed. Param query and param update will be both null. Therefore, both of these will be skipped. So all you have is show menu and then end HTML. So that's the initial screen. So as you click on query, it'll re-execute the script, but the param query will return non-null, and you execute the body of this if statement, and skip the update, skip this second if body, and print end HTML. If you click on update, then it'll execute the second if body and skip the first if body. So every time you go from start from the top and execute different branches depending on what button you clicked. So that's the main program. Now you need to write the subroutines like show menu and read file, edit data. So that's the screen after you click on query. So display the initial screen. It's pretty straightforward. So print start form, print end form, and print H1. This is level 1 header. Supplier database, which is this line, and print a pop-up menu with 2 entries, name and phone. The widget, the menu widget, has a name field. So this field, this name will be used later to retrieve the value of this widget. So which one you selected? So this pop-up menu has 2 entries, name and phone. So this is name and phone. And then print match, print text field pattern, print submit query. So this is a built-in function again in the standard package, which gives you a button, and the query quote. This is the label you specify. If you don't specify any label, it'll default to submit as the label. So here we change it to query as the label. So that's the initial menu screen. Now, read file. So read file reads the file specified by parameter file name and initialize the per hash structure. So the file looks like this. So this file has 2 lines. Each line has 3 parts separated by commas. And each part is double quoted string. So the first part should be ID, second part should be name, third part should be phone number. So this database now has 2 entries. So after you read in the file, you have a hash structure. Now this looks a little strange from a hash learned in class, because this is not covered in class. This is a 2-dimensional hash. We only cover 1-dimensional hash, right? A hash, remember, you hash from a key to a value. But now this allows you to have 2 keys. Supplier A001 name equals apricot. So 2 keys. One is ID, one is the string NAME. And supplier A001 phone equals 224567. So it's a very natural concept, the 2-dimensional hash, right? So think of arrays in Java or C++. How do you construct a 2-dimensional array? You just construct an array of arrays, right? So hash here is the same. Just think of the you have 2 keys, and both keys must match for the entry to match. So supplier D01 name Dixon, that's the second line, and supplier D001 phone is 22022, etc. So this is what you want to do. Go from the text file to the main memory data structure in the form of 2-dimensional hash. So how do you do that? So first sub, that's the subroutine keyword in Perl. Open in file. So in file is a file handle. You use this handle to read the file later. And this is the first argument to the subroutine. So while in file, so if you recall, this is the easy way to read in the file, right? So every time you read in a line from the in file handle and store the line in $_, which is the default variable, you store the line. If you don't specify the variable name explicitly, if you say variable name equals in file, you can store in some other variable name. So if you only say while in file angular brackets, it'll read in one line at a time and store the line in $_, which includes the new line. Trailing new line. So every time you get a string, a line, which is a string, you do split. Split is this built-in function for generating a list of strings from a single string by treating the comma as a separator. So you have a / comma which escapes the comma to mean that comma, you treat the comma as a literal comma instead of having any special meaning. So as a result, this guy add fields, remember add indicates array variable while $ indicates scalar variable. So add fields now is for example, the first line here, after you do the split, add fields will consist of 3 entries. It's a 3-element array. First element is A001, second element is apricot, third element is the phone number. And then you do regular expression matching. to grab the different fields. So $ID is store each field in a separate scalar variable. So what is $ampersand? If you remember, $ampersand is the part of the string that matched the pattern. Back quote is the part of string before the match, and single quote is the part of string after the match. So after you do a match, say so just a brief review. So this is the string, and this is regular expression. So regular expression says space in space. So because you didn't specify any string name in the regular expression, it will match against a $_ by default. So it will match this guy. Therefore, $backquote will contain the stuff before the match, which is Bill Shakespeare, and $ampersand will contain the match itself, which is space in space, and love is the single quote. That's the string after the match. So essentially, this you match each one and store the match within the two-dimensional hash structure. So this is the two-dimensional hash with the ID as the first dimension key and name AIB as the second dimension key, and the value is the current match. So I think this regular expression essentially skips over the double quotes. So it only grabs the stuff surrounded by the double quotes. So after you've done that, then you go to the second line and parse the line with split, and then store each entry in the double hash until you reach the end of the file. So in this case, you only have 2 lines. Therefore, you will, as the result, you will have these hash data structures initialized. So this is read file. So now after you read the file, you display the selected records and allow editing of editable text boxes. Only display the records that contain text matching the field specified by parameter field to the pattern specified by parameter pattern. Display them in ascending order of supplier number and in a table format. That is, it should be sorted order. Only name and phone are allowed for editing. Do not allow editing of ID field. Include update button so that pressing it triggers update of the data, include a cancel button, so that when they pressing it, the web page returns the initial string. So when we display the records at hidden fields like ID1 equals 8001, etc. to each record, so that these parameters are set when the user presses the update button. So hidden fields are on the web page. They're there. You can grab the values, but they're not visible to the user. So the other corresponding parameters will be name1, name2, phone1, phone2, etc. Then you can process each record with ID1, ID2 until IDN is not defined. So let's look at the program, edit data. So you grab the value of the field widget, which is this guy. So this is the field widget, either name or phone. This is the pop-up menu. And grab the pattern widget, value of the pattern widget, and store it in scalar variable pattern, which is this text box. So if you recall, field is the widget name when you created the widget, and pattern is the widget name when you created the text field. You call it pattern. So after you've done this, in the future you can refer and grab the values of the widgets by using their names. So using the parentheses name of the widget. So of course you can enter null value, and they can be null. And then print result field matches pattern. So if I say APR star, it'll say result name matches APR star. Name is the value of the widget pop-up menu, and APR star is the value of the widget pattern text field. So, and then print start form. Print two buttons. One is update, one is cancel, and print the table. If you recall, table has a table row and table data cell. So for each, so supplier, if you recall, supplier is the hash variable you constructed earlier by reading from the file. Keys is the keys, collection of keys of the hash, and source the keys. If it's two-dimensional keys, you sort it by the first key. And for each of the sorted key, you do a regular expression matching. So you match the pattern. So you surround this pattern scalar variable with the / indicating it's a regular expression. And this is match, equal tilde. It's the match. And you match the value of the two-dimensional hash to the pattern. So, of course, if you can omit the first part, then you match $_ against the pattern. But here we can't omit it because we're matching against this variable here, which is one value of the hash data structure. If the match is successful, then you go into the body of the if and grab the name scalar variable as the value of the hash with the key and NA and E as the two keys, with the ID as $S and NA and E as the second key and phone number, and you print this guy. So this print essentially prints the this column ID A001. Now, if you notice, A001 is just a simple text. Unlike the next two entries, which are actually text boxes you can type stuff into. So that's why you say print this ID and print hidden ID $J and $S. So this is it prints out a text box, but it's hidden from the user. Therefore, you cannot use it to enter any data. The whole point of having it there is to be able to associate the ID with each row, so you can grab the data based on the ID later. And then you print a text field with the text field name. $J is this counter you use to assign a unique name to each widget. So the first this text box will have the widget name 1. And if you have two rows, the second row's text box will be name 2, and etc. So this way you can have unique name for each widget. So J is 1, and every time you you display one row, you increment J. So and finally, you print int table, HTML tag. So as a result, so what happens if you click on the query with a null pattern? It will display all the entries. Why? Because now the pattern is null, which matches any string. The null regular expression matches any string. But if you specify a non-trivial pattern, it will match the pattern against either the name or the phone fields, and only display only execute its body of the if and display the row if there's a match. Otherwise, this body is skipped, and then you go on to the next entry in the table. Next entry in the hash structure. So this program is actually you can think of as kind of interaction, right? You read the data from the disk from a file into a hash data structure, and then you manipulate the hash data structure to display and update. You can also do it more directly by reading from the file and doing the matching and displaying directly and skipping the hash data structure. You can say, while input file and process each line in turn. So that will also work. But this way of writing the program is perhaps more extensible. So in the future, if you want to do some more fancy things with your data, perhaps having a hash data structure will be very flexible and very useful. So update the data. So per subprogram to update the record in the internal port hash structure. Notice that it doesn't update the file yet, only updates the hash structure, data structure. Records are specified by the parameters posted from the web page, whose corresponding field values are name1, name2, and phone1, phone2, etc. So you grab every line of the table. Notice that ID $I, so I is a counter, the is from 1 and upwards. It is a hidden widget, right? We specify hidden, so it's not shown on the web page, but it's there. So you iterate over each of the non-null ID values and grab the ID, name, and phone. Notice that you establish this correspondence by the suffix to this widget name. So ID1, name1, phone 1 is a tuple. ID3, name3, and phone 3 is another tuple. This way you won't confuse and match different records. So, and then you store these values into the internal two-dimensional hash and iterate until param ID returns a null, which means that you have exhausted all the table entries. And finally, you write the file to disk. So this subroutine takes a parameter at the file name. So you store it in $fn and open. Alt F is the file handle. You have this greater than, which indicates you're opening it for writing. If you don't have the greater than, then you're opening it for reading. And for each each key in the sorted keys, you print each ID, name, and phone surrounded by double quotes, because then you have to escape double quotes with the backslash double quote, string backslash double quote. And finally, don't forget to close it. Unless you close it, it won't be actually written. So close actually flushes the file from any cache you have to actually to the hard disk. So this exercise essentially tests your knowledge of the hash data structure and the file I/O. So, and also CGI script, how do you print out the web page, and how do you refer to each widget by name, by a unique name, assigning each unique name to each widget, and then grabbing data from it and saving data to it. Okay, any questions on this CGI script? So you should go back and study it. So this by the way, so this is the script. So suppose you know the script path. I found out there's no easy way to save it. So suppose you know the path is here. So how do you save it? If you right click and say save link as, it actually doesn't work. It will save a bunch of HTML. So that's why I put another link here, said download source, where I change the subscript, change the suffix to be database CGI.src. Therefore, it won't treat it as a CGI program, and will actually ask you to save it or display it or open it. So you can okay, so server push and client pull. So there's two patterns of interaction between the client and server. So you're sitting at a computer, and most of the time you do pull. You pull data by clicking on the link, and then you establish an HTTP session, and the web server gives you the data per request. But sometimes you want servers to be able to push new data to the browser. For example, a businessman who wants to see news articles every 5 minutes, refreshed every 5 minutes automatically without having him to click the refresh button manually. So just open up the web browser and you have the up-to-date articles automatically. So that's the idea behind server push. So browsers recently added two complementary methods for generating dynamic documents. One is server push and client pull. So here it's recently, but it's not that recent anymore nowadays. It's perhaps recent 10 years ago. So server push, server sends a chunk of data, browser displays the data, but leaves the connection open. So you establish an HTTP connection, a session, and it's kept open, kept alive. And whenever the server wants, it sends more data, and browser displays it, leaving the connection open. So client pull is where the server sends a chunk of data, including a command that says, reload this data in 5 seconds, or go load this other URL in 10 seconds. After getting this command, the client will reload the current data or get the new data based on the periodic time specified in the command. So in server push, a HTTP connection is held open for an indefinite period of time until the server sends a terminator or until the client interrupts the connection, perhaps by closing the browser. In client pull, HTTP connection is never held open. The client is told when to open a new connection and what data to get. So have this analogy here. Server push is like when you're talking on the phone with your girlfriend, and or even if you talk for a while, she talks for a while, you start watching TV, she's shopping for clothes, but you never hang up. So kind of like walkie-talkie, right? The stuff that police use, they talk to each other, and this line is always open. So a client pull is like making several phone calls only when you have something to say. Call your mom and tell her you will be home at 6 p.m., then you hang up. That is, you close the HTTP connection. Later you call her again. That is, you establish a new connection and tell her it will be 8 p.m., then you hang up. And finally you call her again and tell her you won't be coming home tonight. So these two paradigms from your daily experience, you know, both have advantages and disadvantages, right? If you're talking very frequently, perhaps it's a good idea to keep the connection open constantly. But if you're only talking very infrequently, very rarely, then perhaps it's not. It's a good idea to hang up and then call later. So depending on the frequency of your communication, you can choose two different paradigms. So client pull example. So here's the HTML document. So now we are working in HTML, not CGI anymore. So everything looks pretty regular. You have a title, you have a head, body. The body simply has one line. Bill is great. So this is a Bill Gates fan. Now you have a weird line here, which you never saw before. So meta HTTP equivalent is refresh. Content is 1. So this is asking the client to refresh the web page every 1 second. So this is the web page. If you look closely, you notice that this thing blinks. That is, it refreshes every 1 second. So this behavior is equivalent to if you click on the refresh button every 1 second. If you do it manually, what the server sees is equivalent to what you have now. This is accomplished by having this meta tag here. This is the command, refresh, and this is the time interval for performing the refresh command in terms of seconds. So this is client pool. Therefore, every time you refresh, you close the connection. Next time you refresh, you open the connection, refresh, you close the connection. If you want to wait for 12 seconds, so you simply say content equals 12. Just make sure that the meta tag is inside the head of your HTML document before any displayed text or images. That is inside the head. So the head is beginning of the head tag, end of the head tag. The meta should be surrounded by the head in here. You can interrupt infinite reloading by pressing the back button on your browser. Or forward, as long as you navigate away from this HTML page, then you interrupt the reloading behavior. So client pool, you can also cause another document to be reloaded by adding another argument, URL equals something. So in addition to HTTP equivalent and content equals something, so I think there's an extra double quote which should not be there. Should be just simply 12 there. So use the full path name, HTTP / etc. Do not use the relative URL. That is relative to your current path name. That won't work in the meta tag. But in the meta, it has to be absolute full path name. So here's two documents. The first one, doc2.html, says refresh every 1 second by loading this URL, not doc2.html, but doc3.html. So document 2 itself says Bill is greater. Now document 3 says Bill is greatest, but it refresh every 1 second by loading this URL, which is doc2.html. So doc2 says reload doc3 every 1 second, and doc3 says reload doc2 every 1 second. As a result, what you have is alternating sequence of doc2, doc3, doc2, doc3. So when you load one of the documents, the browser will load the other one in 1 second, and then first, then another second again, and so on. So here's dot 2. It'll alternate between dot 2 and dot 3 infinitely, periodically every second. So how do you stop this? You close the window or just simply change the address, but navigating away from these 2 pages. Of course, in this case, the back and forward doesn't work anymore because it does work. So, yeah, so it's not in the history. So, yeah, just navigate away from it. The reload interval can be 0 seconds, which will cause the browser to load the new data as soon as it possibly can after the current data is fully displayed. Therefore, the fun thing to do is to have a 0-second update of a series of still images for a poor man's animation. So you display a series of images, one slightly different from the other, and as a result, you get a kind of animation effect. And also, it can be useful. For example, if you change your homepage address, if you move to a different place, right? So you can place a link on your old homepage that says, "I have moved to the new address." Or you can do specify the redirection with, say, 10 seconds, and you can say, "I have moved to a new place. You will be redirected in 10 minutes, 10 seconds." So sometimes you see these redirection links on people's home pages. Or you can specify 0 seconds as the interval, so that as soon as people click on your old homepage, they will be automatically redirected to a new homepage without even knowing it. So server push is another dynamic document method which uses a connection that is held open over multiple responses so that the server can send more data anytime it wants. The advantage is that the server has total control over when and how often new data is sent. It can be more efficient since new HTTP connections do not have to be opened and closed all the time, so it can be faster. And server push is easily interruptible. You can just simply hit stop and interrupt the connection. So to access server push from the web page, the URL is slightly different from the regular CGI programs. So now we're coming back to CGI. So you have the extra thing here that's non-parsed headers in the CGI wrapper program. If you forget the NTH prefix, then you get an error. So otherwise, the rest of the path is the same as the regular CGI program. So here's the. So let's look at the behavior. Server push counter example. So there's a page has been called 1, 2, 3, 4, 5, 6, 7, 9, and then counter finished. 10 iterations. So let's see it again. Yeah, so that's the behavior. Now, so following lines will be displayed until the counter reaches 9, and finally it'll say counter finished in 10 iterations. So you have this line here, say use CGI colon colon push. So this is different from the previous use statement where we didn't have the push. Now this is a new library. We are a new module we are including. It's called CGI push module. And then after you include this module, you can do push. So do push is this keyword. It has 3 arguments. Input references to 2 functions. Dash next page. This guy is like a arrow, equal or greater than. And this guy, next page, is the function name in Perl. The last page is another function name. And the first function, that is next page, is called repeatedly until returning undef. That is, as long as its return value is not undef, it'll call this function repeatedly, but it'll stop calling this function when it gets undef back. And at which time last page will be called once only. And the delay is the number of seconds between reloads. That is between the execution of next page, different executions of next page function, or next page between next page and last page. This is the 0.5 second between the invocation of any 2 functions. So of course you can name these functions, subroutines, with any name you like. You happen to name it next underscore page. You can name it anything you like, except the first part must be dash next page. But the function name itself can be anything. So here's the next page subroutine for the example. So this line, remember my essentially creates private copies, local copies of the data of the variables. Instead of, if you didn't have the my, then every variable will be global scope. So having the my is a good idea to maintain modularity in Perl. So it's different from C, right? In C, the variables in each subroutine, each function is automatically private to that function. But here we have to use an explicit my to indicate private variables in that subroutine. So push module will pass 2 scalars to the function. The second scalar is how many times the function has been called. So this is the array of arguments, list of arguments to the subroutine. If you recall, yeah, this is a built-in notation. So add underscore indicates the list of arguments to the subroutine. The second scalar variable in the list is the number of times the function has been called. So you assign this number of times to the scalar variable counter. So you say, wait a minute, I didn't pass any arguments, right? You know, when you said push this guy, you didn't pass any arguments. But these arguments are passed implicitly within the do push. So that is the push module will pass these two scalars to the function as their arguments. You didn't do it. It's done by the doPush built-in function, so that you have available the how many times the function has been called. This information is available to you provided by the doPush, so you can use it in your code. So how do you use it? If counter is greater than or equal to 10, if you have counted up to 10, return undef, which means that you're done. You should go and invoke the last page subroutine now. Otherwise, you return start HTML counter, which is the title of the document, H1 counter, which is the level 1 header. So if you look at this, so the first argument counter shows up on the top of the browser bar, which is the title. The second argument is the header in the body of the HTML. New line, and this page has been called strong, which is keyword for emphasis, which is italic. We translate into HTML. Counter, which is the number of times, how many times this function has been called, times in HTML. So the first time this subroutine is invoked, it will say this page has been called 1 times, which is not correct in terms of grammar, but in any case. And next time this called, it will say it's been called 2 times, because now counter is now true, etc. until you reach 10, and then it returns undef by skipping the this line is skipped, so that you do not print the line this page has been called 10 times. You only print up to 9 times. Part of the counter is now 10. So on the last page, same line here, grab how many times this subroutine has been called, and say counter done is the title, counter finished is the level 1 header, and counter number of iterations. Now counter is equal to 10 because you are counting up to you have invoked this doPush 10 times. You have pushed contents 10 times. The first 9 times you have printed out. I have counted how many times, and the last time you print out counter finished 10 iterations. So this is only called once at the end to display the final HTML page. So notice the counter is how many times the function has been called. So this is really how many times this doPush has been called, not how many times the subroutine has been called. So last page is only called once, but counter is equal to 10 because doPush has been called 10 times. So, so no questions? Any questions on this one? Oh yes.
Q. The next slide. Yeah. The Q. What the Q store the value?
This Q? I don't know either. So, so this is essentially these are built-in within the do push function. So counter the second element in the list of arguments in add underscore is the counter. How many times function the do push has been called? The first one, I don't know what it does. You can look it up. So it's not relevant to us, to this function at least. So another example shows the current time indefinitely and updating the time every second. So it updates it every second, like a ticking clock. So how do you do that? Same thing here, and local time. Local time is the keyword for grabbing the local computer time, that is the web server's computer time, and scatter the built-in function to convert it into easy-to-read format, which is this format: Friday, April 17th, etc. So, and the delay is 1 second. Therefore, it'll execute this date page, call the subroutine every 1 second, and display the current time. So notice that these two functions are the same. Date page for both the next page and last page subroutines, which means that this is an infinite program. That is, it will never terminate. Unlike the previous one, which terminates after 10 iterations. Okay? Just another reminder, when you are working on server push, always remember to add NPH, non-part header, to in front of the CGI wrap. Otherwise, you get an error. Okay, so let us go over the past exams. So next class we'll go over some more exams. So the first few questions just test your knowledge of Unix utilities. This is really memorize commands, essentially. What commands list the contents of the file named webpage with the first 15 lines skipped? So it's a more plus 16 or tail plus 16. So this essentially displays the line from the 16th lines downwards. I think we didn't cover these commands in the lecture notes. So in the exam, we'll only cover stuff in the lecture notes. If it's not in the lecture notes, you don't have to know it. So this is an old exam. So every semester we have slightly different lecture contents. So rename the file comp000 to comp111. So very easy. Move. By the way, if you're working on DOS, it's REN, rename. But if it's on Unix, it's move. So what's wrong with this command? unique. Unique takes a file and only and pulls out the unique lines. That is, if two lines are identical, it only keeps one line. So sorts the file by the first alphabetically. So the intention is to do a unique and pipe the output of the unique command to sort. However, something is wrong because sort has two inputs. On the left, from the output of the unique command through a pipe. On the right, from the S file 1. So in Unix, commands only allow one input and one output. So you shouldn't have two inputs. And also remember the difference between pipe and less than greater than. So pipe connects two commands, moves the output of one command to the input of another command, while less than greater than connects a file and a command. So it redirects the input and output of a command to or from the file. So write a command to find the lines in the file B, which contain the pattern texture, and sort the result and write the result to a file named file C. So grep texture, which is the regular expression you want to search for, and file name, pipe the output of the grep command to the input of the sort command, and redirect the output to file C. So this just tests your knowledge of Unix I/O redirection. So you have two files with these permission bits, a directory with these permission bits. So remember, the first letter indicates if it's a file or directory, D indicates a directory, and then the next three letter indicates the permissions for the user, read, write, execute. The next three indicates permission for the group, and the next three indicates permission for others. So the first letter, so the secret is a directory, is a D, while the owner has read permission and execute permission, and group and others all have read and execute permission, not write permission. So ls list -l lists the contents of the secret directory, which contains a file with read-write permission for the user, read permission only for the group, and read permission only for others. Now you want to try to copy names, which is the this file, to secret letter 1, which means that you want to overwrite the letter 1 file with the names file's content within the secret directory. So what will happen? It will say, cannot create regular file secret letter 1, permission denied. Why? Because the owner of the file is Horner, username is Horner, Well, the current logged in user is CS Chong. Therefore, CS Chong is either in the same group of Horner or not. Therefore, it will use either this permission bits or these permission bits, but not the first three permission bits for the user, because CS Chong is not the owner of the ledger1 file. Right? If the who am I returns a Horner, then you can override it. Because the reason is because user doesn't have write permission. So look at the next commands. Now the secret directory has no permissions for anyone, including the owner. Can't read, can't write, can't do anything. So do an LS, obviously, it'll give you permission denied. You chmod it, user plus read write. Now you can do it because the who am I returns the user CS Chong, which is the owner of the file. Owner of the file can do anything. Right? So you can do chmod, change mode, give the user rewrite permission. Now you do an LS. What happens? Everything permission denied. So the directory, you give the user the read and write permission, but not execute permission. Well, what is execute for directory? Execute for a file is easy to understand. It's executable file. But for directory, it means something different. It means to list the content of the directory. Think of a directory as a phone book. X indicates you can read the phone book to see what entries are there. So, well, the R permission only says, I gave you the permission to see the attributes of the directory itself. Right? If the secret directory has, a creation time and all that, then you can see it. But X really lets you see the content of the directory. Because you don't have X here, you cannot see, you cannot do LS secret. So because user doesn't have execute permission on the directory, so here the execute permission is really not very accurate. It's not execute. It doesn't make sense to execute any directories. It's really reusing the bits to mean something different. It means to list the content of the directory. So look at this this guy. You have two files, one directory. You list the directory contents. So notice that owner is Horner, while user is CS Chong, but even the non-user, non-owner can have read and execute permission. Therefore, CS Chong can list the contents of the secret directory. And then you copy named file to overwrite ledger1 file in the secret directory. Because you only have read and execute. Therefore, and ledger1 you only have read permission. Because CS Chong is not the owner, not the user, so you cannot use the first 3 bits. You have to use the either this or this 3 bits. Therefore, you do not have write permission. So you don't have write permission on the file owned by Horner. So this guy, did I see this before? So it's the same. Yeah, same example. Yeah, somehow I got the second one, explain the second one first. So anyway, so here's the example. You have a letter 1 file, you schmal it, change the mode to 700, which means that you grant, remember 7 is 111, right? You grant rewrite execute permission to the user of letter 1. Can you do it? No, because who am I is Horner. So Horner cannot change the mode of the file owned by CS Strong. Only the owner can do it. So only the owner can change the permission. So what are the contents of these files after these commands? So it's hard to explain without without the ability to draw. So let's try, okay? So first command, date, redirect output of date to A1. So now A1 content is date. Actually, the actual date, which is 2009, April, etc. So we use the date to represent that string. So A1 contains the second line. A2 contains pwd command, which is my current directory. Now this command says L10 establish a link -s symbolic link. So A4 points to A1. So now A1 is the file, A4 is the symbolic link. Don't get the direction confused. A4 points to A1. Now who, double arrow, double angular bracket A2. Now A2 contains the result of who. So double arrow means that you're appending to the file. So now it's that it has the content contains pwd and who. Now L10 A2 A3. Now A3 points to A2. Now this is a hard link, not a symbolic link. Therefore, A3 and A2 are symmetric. So actually really say A3 and A2 point to the same file. You shouldn't say someone points to another because these two are symmetric now. Now PWD A3, what does this do? This appends PWD to A3 because A3 points to A2, they're symmetric, so this really nullifies A2. So finally, this guy, so this has different behavior on different machines. On Solaris, it'll overwrite what was in A1, but on Linux, I forgot which one is which, but sometimes you overwrite, sometimes it'll say permission denied, you cannot overwrite, the file exists. If you really want to overwrite, you can say exclamation mark, then it'll overwrite. So after this command, it'll replace the content of A1 with who. So that's the result after executing the sequence of commands. So on Sun, it'll overwrite A1. So A1 contains this, A2 contains this, A3 is a hard link, so it contains the same content as A2. A4 contains who because A4 is a soft link, symbolic link. So it contains the same content as A1. If it's on Linux, this command who will result in A1 file exists. Therefore, it won't allow you to overwrite it. So A1 still contains state, not who. So look at this one. After the first command, F1 contains date, F2 contains who, S1 is a symbolic link to F1, S2 is a hard link to F2. Now, what happens if we remove F1? F1 is gone. Now the link is a dangling pointer. S1 is a symbolic link, therefore it's a dangling pointer. But if you remove F2, S2 and F2 are symmetric. They're hard links. Therefore, the file is still there. S2 is still a valid file, not a dangling pointer like S1. Right, you see the difference? If you have a symbolic link, then you remove the original file, the file is gone. All the links to it are dangling pointers. While if you have hard links, then only when all the hard links are removed, then the file is deleted. Otherwise, if you have even only a single hard link exists, the file is still there. Therefore, the first remove F1 will actually delete the file and make all the symbolic links invalid. The second remove F2 will not delete the file because there's another hard link to it, S2. Only if you do remove S2 will the file be deleted. So cat S1 will show cannot open S1 because the link is no longer valid, or cat S2 will actually return the valid content of the S2. So soft link is a pointer to the linked file name. The hard link is a pointer to the inode. Inode is the actual content of the file. Therefore, you can create a soft link to a directory, but you cannot create a hard link to a directory. There's another difference between soft links and hard links. Use one command to list all the lines in the file text with the character star. So you say grep star text. Now, you have the escape here because star means something in early expression. If you only have a star, it will match every single line. If you have escape star, backslash escape, or double quote star, it will actually match the literal star character. What is the working directory after executing the following command? So you're now in this directory, you execute this command, cd, user bin, blah blah blah. So this is actually a trick question. Doesn't matter what you do. The only thing that matters is the last cd, which goes to the home directory, which is the same as the tilde directory. cd is the same as cd tilde. So, and also remember, any CDs you do within the parentheses do not have any effect outside the parentheses. So if you had a CD, say higher directory, then what you do within here doesn't have any effect. All you have effect, you can essentially delete this part. It won't affect the correctness of your result. But here you have a CD in the end. Therefore, it doesn't matter what you do before the CD. The last command will lead you to the home directory. So hello is used to display the content of the text file. Fill in the blanks. So hello is like a cat, except you write the cat command yourself instead of using the pushing cat command. So actually the answer is, if you copy a string to the TTY device, then it'll display the content of the first file, $1 file, on the TTY device, which is the current display. So this command has the same effect as cat. Copy the first argument. So $0 is the command name itself. $1 is the first argument to the command. Copy the content of the file to the TTY device. So I think we didn't really discuss this in class. So the meaning of this shell command, users is, notice the back quotes. Back quotes means execute the command and place the output of the command within the into the variable users. If you didn't have back quotes, it'll simply put the string itself, WHO, into the user's variable. But back quote means execute it and put the output. Who gives you a list of logged in users, pipe the output of who to word count -r. Word count dash L counts number of lines of the file. So, and so now users contains the number of lines in the who output, which is number of users. Also notice that this is a shell script, therefore when we're doing assignments, you don't have the dollar. When we're doing read, you're using the variable, you have the dollar. But in the per script, you have dollar always for any scalar variable. So calculate factorial, fill in the blanks. So this is a pretty straightforward regular recursive procedure. So the answer is this. So I'll just let you read it. Very similar to the example in class of recursively printing out the contents of the directory sheet. So while I less than equal to n, output is the XPR means that you only evaluate this arithmetic expression. Actually, I think I said something wrong. This is not recursion. This is iteration. Yeah, iteration. So this is computing the factorial by like a for loop. Right? You have two ways of computing factorial. One is recursion, one is iteration. Remember? So this is really just iterating each I from 1 up to n and multiplying I onto the output variable. I think you can write a recursive version, but this is not recursion. So the following shell program calculates the sum of all the arguments. So if you say calculate 1, 2, 3, it'll return sum of three numbers is 6. Calculate this, it'll return 55. So finish the shell program. So you're given. So here's the program. So this tests the knowledge of arguments. So $0 is the command itself. The command name itself. $1 is the first argument. $2 is the second argument, etc. $pound is the number of arguments. So you say while $1 is valid, you add it to the sum shift. So shift means that move everything left to the left by one position. So the now the new $1 is the old $2, new $2 is the old $3. And the old $1 is gone. It's no longer accessible. Therefore, this do loop will essentially shift, add, shift, add, shift, add until you exhaust the list of arguments. Of course, another way of writing the program is simply to use the $pound and iterate over the arguments that way, which is more. But the problem description says finish the program without defining any new variables. So I think this way is the way to do it. So if you say like a for loop style, for I equals 0 to $pound and iterate over arguments, then I think you need a new variable to iterate, like a counter. Therefore, it won't fulfill the requirement of the problem statement. So this is recursively list all the directories and files within the directory. I think this is actually placed in the lecture notes. Fill in the blanks, and this is a recursion. So list file is the name of the script, and you go into the directory, and for each file you echo the file name, and if the file itself is a directory, then you call the script itself, passing in the directory at the argument. It's a simplified version of the example in your lecture notes. Or even, I believe this is. Did you do this in your lab? Throw a dice if you win, odds you win some money, even you didn't? Okay. So computer throw a dice. If the user has to guess, if the user guesses correctly, then he wins some money. Otherwise, he loses some money. So fill in the blanks. So here's the program. srand seeds the random number generator. S stands for seed, seeding the random number generator. So money is 1,000. Initially, I have $1,000. So dice is this random number. A dice has 6 sides, right? 1, 2, 3, 4, 5, 6. So rand 6 returns a floating point number less than 6. So you convert it to integer and plus 1. This will give you a random value within the range 1, 2, 3, 4, 5, 6. It's like throwing a dice. So if the dice modulo 2 is 0, then it's an even number, and you take the input from stdin, guess and bet, and if guess is equal to the result, you guess right. Then so this program is a partial program to fill in the blank of the earlier program. So you win and computer loses. Otherwise, you lose, computer wins, etc. So it's a pretty simple program. So string produces the following output. Input two numbers, input both 0 to quit. First is 2, second 3, then 3 to the power of 2 is 9. 3 concatenated with 2 is 3, 2. 1, 1, 1 to the power of 1 is 1, 1 concatenated with 1 is 1, 1. 0, 0, then you quit. So this is the program, and it contains some errors. You need to correct it. So you can spend a few minutes to see what's wrong with it. The first line, which I didn't show you, is already wrong because you need a exclamation mark here, right? So, and while true, there's no true keyword in Perl. You must have 1. True is in C, not in Perl. And I equals something. So this is a Perl script, therefore you must have $, not a shell script. It's a shell script, you don't have, you do not have the $when you're assigning the variable, but it's a Perl, so you need to have $. And you need to chunk. Remove the new line. Same here. So, if equals 0, this should be double equal, not EQ, because EQ is a string comparison, while this equal is a numeric comparison. And power is star star, not tilde. Tilde is not a valid operator in Perl. What's concatenation? Concatenation is dot, not plus. So finally, to the power, this guy, you should have curly braces because you have an S directly following it, because the variable name is greedy. If you didn't have it, say this, it'll look for a variable called $IIS, which doesn't exist. So if you want to have a variable name, variable name followed by is, without a space in between, you must surround the variable name with the curly braces. Of course, if the space in the middle, then the curly braces are optional. Otherwise, you need to separate the variable name from the is following it. Same here. So, okay, just some syntax issues. You then probably should give the following output. I think this is a very easy one. If your input is backslash, just echo backslash. If it's $, echo $. Otherwise, you say input another character. So this is just make sure that you escape it. That is backslash or backslash $. Otherwise, the regular expression will a $, means something special in the regular expression. I also use EQ, not double equal. EQ is stringwise comparison, while double equal is numeric comparison. What is the value of n after the following per statements? So this is just a little tedious. You just need to grab a pen and work it out. Nothing really deep about it. You have two array variables, and you iterate over each element of the array, index into the another array, and do computations. So nothing deep. Next one, same here. Also very tedious. You just keep the arrays straight. So put the new element to the right of the array. Pop the element off the right of the array. Shift, unshift, add the new element to the left of the array, and shift, remove the element from the left of the array. Just keep that straight, and you can do it. So push pop operates on the right, and shift unshift operates on the left. Next question is shift unshift. What about this one? So you have an array variable which has 4 entries, 1, 2, 3, 4. Now what does this do? This says assign a array variable to a scalar variable. That is very strange, right? Now, what this does is really using the array variable in the scalar context. It actually assigns the size of the array variable to the scalar variable, which is 4. The next line says assign the array variable to another array variable. Because you have a parentheses, then on the left you also have an array variable. Therefore, after 2, the scalar variable will get value 1, which is the first element of the E array variable. So the first line here, the @E array variable is used in the scalar context. Therefore, it is treated as the size of the array. The second line it's used in the array list context, therefore it's treated as a list. And because on the left you only have one element in the list, then you only grab the first element of @E and discard all the rest. Therefore, output is 4 and 1. Control flow. Identify that the arguments are reversible. That is, you have the same value if they're reversed. So this is also called so-called anagrams in English. That is, if you have 1, 2, 2, 1, if you reverse it, it's also 1, 2, 2, 1. Therefore, they're reversible. But I have 1, 2, 3, 4, 5. If you reverse it to 5, 4, 3, 2, 1, they're not reversible. So how do you do that? So for each so this is just a hint to you to access the input arguments using the array add argv in Per. I think we didn't discuss it in class. but you can do it. So having this knowledge, how do you write the program? So the program now is this. You have this, while this argument list is larger than 0, that is non-zero, you compare the 0th element to the minus 1th element. What is minus 1th element? It is the last element, right? Arg v minus 1 is the last entry of the array. If the 0th is different from the last, then you know it's not reversible because it's not symmetric. Now now you go last. Last is the control flow statement to go to the to escape, to exit the loop. Now, if these two are the same, then what you want to do is to compare the 1th argument with the minus 2th argument, right? So, and see, and every time you compare, you go inside one step. So the way to do it is to do a shift and do a pop. Shift moves all the elements to the left by one position and removes the leftmost element. Pop moves all the elements to the right by one position and deletes the rightmost element. The result of these two operations is to remove the left and rightmost elements. Right? So if you had 1, 2, 2, 1 before, now you only have 2, 2. Now, after you've done it, if add arg v less than or equal to 0, which means that you have exhausted the argument. If it's equal to 0, you have exhausted the argument. If it's equal to 1, if it's less than 0, yeah. So here add arg v is using the scalar context, even though it's a list variable. Therefore, it's the size of the array. So you're comparing left and rightmost elements, and then you're discarding the left and right elements if they're the same, comparing the next left and right elements, and discarding them, and comparing the left and right elements again, until you exhaust all the entire list. If you go to the very end, and you get to 0 arguments, you can say the arguments are reversible. Otherwise, if you exit in the middle, you detect something that's not the same, you exit from here, then the arguments are not reversible. Okay, any questions? Okay, next class we'll do more reviews, and then we'll have the test. See you.